Okay, let's talk about reading a graph. So again, we're reading a graph from left to right. So now we're looking at intervals for a graph. So we're increasing, okay, basically this means I'm going up as I go left to right. Okay, so like so. I'm going in this direction, up. Decreasing, I'm going down from left to right. Constant is when the graph is flat, so horizontal. Okay, we have a relative max and a relative min. That's going to refer to the curves on the graph. So a relative max and a relative min are going to be the curves. So the max would be the highest curve. The min would be the lowest curve on the graph that you can see. So let's do that with this graph here. Thank you. Okay, so if I'm looking at this graph, first of all, I'm starting down here. It's going off the graph, so it's an arrow. And if I go from left to right, I'm going up. Okay, so I am increasing from here, and then I'm going to stop about right there, and that's where I change direction at this point right here. Okay, so this is increase. We'll just put an I for increase. Then I change direction at this point here. Let's mark what that point is. It looks like that is about -1, and then we're going to say that's about 2.5. Then I change direction and start going down, left to right. So we're going to put a D for decreasing. And I change direction at this point, which looks like that is +1, -2.5. And then I change direction, and I start going up, and then again off the graph. So I'm going to put an I for increasing. Okay, so I am increasing from this point here, which is going to keep going down, and also to the left, towards -infinity. So I'm increasing from -infinity, and when we're doing this, all of these, when we're reading the graph, we're always referring to x values. Okay, so you're reading these as x values. So I'm going from -infinity until I change direction right here at this point, which had the x value -1. Not only am I always doing x values, when I'm reading the graph and I'm doing the intervals, this is called the intervals of the graph, I'm using parentheses. Okay, so I want the x values and I want parentheses. Okay, then I'm decreasing from this point, and again, I want the x value, so I'm decreasing from -1 to this point here, +1. Again, that'll get parentheses. And then I'm increasing again from +1 to +infinity. So here I just put a comma, 1, +infinity. I'm not flat anywhere. I'm not constant at all, so I can skip that. The relative max on this graph is the higher hump. So if I look at the two humps where it changes direction, this one's higher. So that's my max. So that's -1, 2.5. The lower hump is going to be my min. So that's +1, -2.5. Zeros. Does anybody know what zeros are? Yeah, those are your x-intercepts. Okay, so I'm crossing the x-axis 3 times. It's really close to -2, and just for it being really easy for us, -2. So -2, 0. I cross it right here at the origin, 0, 0. And again at, we'll say that's +2, 0. Okay, the value for f of -3. So I want -3 on my x-axis. What is the y value? Here's -3. That's a really not a straight line at all. We come down here, and maybe about like right here, we'll say -15. Okay, we're just estimating on this graph. If you have one on your homework, you'll be able to zoom in and see very clearly. Value for f of x equals 5. They're giving you the y value 5. What is that x value? So here's the y value 5. And that looks like that's about 2.5. So we'll say x equals 2.5 there. All right, so all of this on your homework is one question. So it's like A through G. So there's a couple of questions that are a little bit long for that particular type of question. Okay, let's look at even or odd functions. So if you go onto the help me solve this or view an example, okay, on your homework, they're going to tell you a different way to do this. Okay, so there's always more than one way to do a type of problem. Sometimes some ways are easier and sometimes there's shortcuts. So here's the way that they're going to show you to do this. So let's do that with this first function here. They're going to tell you to plug f of -x into the function. Okay, so let's say we do that. We've got f of -x equals -x to the 5th plus 1. Okay, you're going to simplify that, and that's an odd function, or an odd exponent, so that's going to come out negative. Okay, and this is what you are looking at. Then you're going to compare it to the other function. How many sign changes did you have? Did all of the signs change? Did none of the signs change, or did one of the signs change? Okay, in this one, you had one sign change. Okay, but not all. So we'll say some sign change. That means it's not either or odd. So that's neither. If all of the signs change, that's odd. And if none of the signs change, that's even. But I don't like doing it like that. There's an easier way. All right. So what we're going to do is we're going to examine the degree of each term in the function, so the exponent. So 5 is an odd number. So that term is odd. The number 1 is a constant. Constants are even. Okay, the reason why we say constants are even is because of this. 1 can also be written as 1x to the 0. 0 is an even number. Okay, what is x to the 0? It's 1. So this is 1 times 1, which is 1. So writing this as 1x to the 0 does not change the value of the constant, therefore it is even. Okay, so all the constants are even. If they're all odd, the function's odd. If they're all even, the function's even. If they're a mix, it's neither. So this one is neither. So let's look at E. First term, we have an exponent of 2. Is that an odd or an even number? Even. Second one, 5, x to the 0. 0 is even. They're both even, therefore the function is even. Okay, in C, you have a 2x squared. 2 is odd or even? Even. 5x to the 4th. 4 is odd or even? What number is on this x? 1. That's x to the 1st is 1, even or odd? Odd. And then this is an x to the 0, even. So you have even, even, odd, even. So it's neither. All right, in D, 5 is even or odd? odd. 3, even or odd. And 1, even or odd. Odd. They're all odd, so this function is odd. E, you've got 2, which is even. X to the first, odd. Constant, x to the 0, even. So this last one, neither. Okay, shortcut way to do that. Again, if you see the f of negative x, that is a valid way to do it easy as well, but it just takes more time. All right, so some practice problems for you guys. Number 3 is a little bit different. So if you don't know how to do that one, that's okay. We will go over that in just a second. So I'll give you guys about 5 minutes to do these. Okay, let's go ahead and go over these. So looking at this graph, I'm starting at the arrow. So really this, you could take this and extend this all the way to the top. It's going up and to the left. Okay, same with on the right. But if I'm going from left to right, I'm actually decreasing, coming down to this point right here, which is 0, negative 1. Then I'm increasing here, and that's just from the, well, we could go here, 1, 3, it looks like. Then I'm decreasing again, and that looks like that's the point 2, negative 1. And then I'm going to change again, and I'm going to increase into infinity. So we're increasing from here to here. Oops, bad drawing. From here to here. So the x value from point to point. I have a hard time sometimes drawing on here. Okay. X value from point to point would be the x value 0 to 1. So the first interval, 0 to 1. Then I'm also increasing from here to infinity, so all the way up here. And that starts at the x value 2 and goes to infinity. Okay, then decreasing, we're decreasing from this point to this point, so that's coming from negative infinity and going to the x value 0. We're doing negative infinity because remember, you're coming from the x value. This is going to keep going up, and eventually it's going to keep going to the left. Okay, so negative infinity to 0. And then again, just this little point here from the x value 1 to the x value 2. Constant, we're not constant at all. The relative max, this max point right here, this highest curve, so 1, 3. And then our relative min, there's 2 of them, because they're at the same horizontal plane here. This would be 0, negative 1, and 2, negative 1. And just to keep going with this, we wanted to do the domain and range. Since both sides of this function are going off the graph for the domain, that would be negative infinity to infinity. And then the range, you have this lowest value at negative 1, and then you're going up to infinity. So the range would be negative 1 to infinity. We'd have a bracket at negative 1, okay, because we're actually touching that point. Okay, remember when you're doing the intervals, it's just parentheses, but when you do domain and range, you do want to determine if it's including that point, and you'll get a bracket. All right, let's look at 2. So for A, did we find that one to be even or odd? Yeah, because you have 2 is even, 12 is even, so this is going to be even. What about B? Neither, yeah, because you have odd, even, this has a 1, so that is odd, and this has a 0, so that is even. This is neither. What about C? Neither as well. This is x to the first, which is odd. This is x to the 0, which is even. So that will also be neither. All right, so this is a piecewise function. Didn't really go over it in the main section because I don't typically test on it, but it might be on your homework. So here all this is a graph that's kind of broken at an x value of 0. Okay, so what this means is that when I'm evaluating the function, if the x value is less than or equal to 0, you're going to use the first one. And if it's greater than 0, you're going to use the second one. So for example, f of -3. Is -3 greater than, less than, or equal to 0? Yeah, it's less than or equal to 0, so we use the first function. So we use 4x plus 4. So we say f of -3 equals 4 times -3 plus 4. So we get 4 times -3, -12, plus 4. That'll give us a -8. And then you have 0. 0 is equal to 0. So we use the less than or equal to 0, which is the 4x plus 4 again. So we would do f of 0 equals 4 times 0 plus 4, which is just going to be 4. Then +3 is greater than 0. So we use the second function. We use x minus 5. So we say f of 3 equals 3 minus 5, which is going to give us -2. And that should be it for 2.2.